Hello everyone and welcome to an update slash tutorial. So if you've watched the previous videos, you know that I use a depth texture like the one you're seeing here, which is, let me show it better to you. Come on, come on, come on. There you go. So this is a depth texture, and I look up the position of the character in world space and I transpose this into a pixel on this depth map, and then I interpolate the grayscale value of that pixel between a maximum value and a minimum value. If it's black, then the value is going to be the minimum, and if it's white, the value is going to be the maximum value. And that's how I update the scale of the character, and that's also how I update its Z position. Now, as you can see, I get lots of errors here when you take the texture and import it right into Unity. At first, it's going to be Sprite 2D and UI. And so the first thing you need to do, of course, is change it to default because it's a texture, it's not a sprite. But I get these errors, and why do I get these errors? Well, it says it's not readable. So I need to make the texture readable. So let's go here in the texture import settings and go read, write, enable, and tick that box. Now that I've done this, great. I don't get the same error. Actually, no, I forgot to apply. So let's apply this. Takes a little bit of while. Okay, great. Nice, it applies. Oh, what do I get here now? Well, it says unsupported graphics format. Forget pixel operation. And the reason we get this error is that the getPixel API, or anything that attempts to read a pixel on the texture, requires the texture to be not compressed. This is a bit annoying though, because you see here, Unity, so the way Unity handles files, you give it whatever file you give it, like it could be a PNG, it could be a PNG, it could be a bitmap, it could be a PSD, whatever you give it as input. Unity is going to import it and turn it into a Unity asset. And it's going to use its own kind of compression format. It's going to use its own thing to make it as good as possible. But it's going to add a lot of extra information in there. So this PNG file, which is a 2040 by 2040, 2048 by 2048, is originally about 500K. And as you can see here, Unity adds a payload of information, making it a 2.7 megabytes file. That's not good. But worst thing is that it is compressed. So you could go and change the quality of compression to make it low quality. That's going to gain you a little bit of performance and a little bit of space, because instead of being 2 bytes per pixel, it's 4 bytes per pixel. It's going to be 2 bytes per pixel. So we have exactly half the place that it takes up. What can we do? But the problem is we are not allowed to use any compression. So we have to pick one of these formats. Now, if I go by the default format, which is RGBA 32 bits, that's 32 bits per pixel. And, well, 32 bits per pixel is 21 megabytes of information in just one texture. You can understand that since this is going to be a mobile game, it's a big no way, sir. We need to figure out some better optimizations. So let's look at what we can do. But the character is getting the right size, right? We're happy with that. What if we, instead of using red, green, and blue and alpha channel, we reduce this to as much as we can? And let's go to just use 8 bits per pixel by just using the alpha channel. What happens if I apply here? Oh, as you can see, my character is not looking too good, because my alpha channel is actually full white. Of course, because this is texture that is fully white. So I could instead, I can remove these sRGB color texture thing because it's useless. I can also remove the generate bitmaps This also adds to the payload because, well, this texture is not going to move, or it's not going to be rendered even, so we don't need maps for this. Let's remove that. That's going to reduce the payload. And then instead of alpha source input texture alpha, let's go with alpha source from grayscale. So this is going to look at the grayscale of the image and turn and just dump that into the alpha channel of our texture, which is exactly what we want. So let's apply. Still, now we've reduced this from 21 megabytes to 4 megabytes. This is already pretty nice, but our character is not updating its size. And the reason is, in my code, I'm using the grayscale in my depth map script. So instead of using the grayscale, what I have to read is the alpha value. So let's just do depth map get pixel.a to read the alpha value of the texture. Now this is great. And this should work. So now my character should have the right size. Awesome. Now we figured that part out, but we still have a 4 megabytes file. This is still way too big. How can we reduce it further? So we could change the size of our texture. We could use actually like a 512 or 256 maybe. Let's go with 512 and see what we get there. And apply. Okay, awesome. Now we have a 256 kilobytes file, which is very reasonable. However, our character is super small. Now, why is that? Well, remember, I told you that I mapped the world position to a pixel on the texture, but that was based on the texture being 2048 by 2048. And now it's 512, so it's actually looking up a pixel that's like super way up here, where it should be looking for a pixel that's kind of like here. So how do I deal with this? Well, in my code for the depth map, I have a pixels per unit thing. And so for 2048 things, I use a pixels per unit of 140. And here I'm going to change this to be a pixels per unit of 35, because we're going to divide this thing by 35. By 4, sorry. And now the character has the right size and everything should run smoothly. Let's see. So let's take Charlie here. Where is she? There you go. Let's move her around. Well, I could actually, I started the game so I could play around with her. And she moves nicely. She gets rendered in front of this thing. What if I go behind the stairs? Well, I'm rendered behind them. What if I go on the stairs? Well, there's still a little bit of mishmash going on here because I need to kind of change where I can go. But I can go on the stairs and be rendered on top of them. Now the stairs are positioned on the Z at this point. So whenever I go actually beyond this point, I can go behind the stairs. So that's kind of how I have to figure it out. Anyways, this is it. Hope you learned something, because I certainly did learn a lot of things trying to figure out how to do this. Thanks, and see you next time.